Okay. All right, can we start? So, everybody, please welcome Luděk Svoboda from sledovanitv and his talk GraphQL in Go. So, hello again. I'm still Luděk. And I will tell you something about GraphQL and about GraphQL in Go especially. I will start with short poll. So, who knows GraphQL? Great. And who has ever tried to do something in GraphQL or using GraphQL? Okay, that's not bad. So, for the other guys, I will say something about GraphQL. It's query language and also API design. It was developed by Facebook and was released in 2015, so it's not so old. It was originally implemented in JavaScript, and as you can see, there is a website with information about it, so you can read more details. So, I will start with schema. GraphQL is a way to model your, to represent your model and to be able to request it from a client. You should provide some schema to clients. It's type. Of course, there are some built-in types like integers, strings, but you can, of course, build your own types, something like structures and list and so on, but it has some specialty. Some fields can have arguments, so you can put some arguments to queries. And in the root of the schema, there is some root object, some root query specified here, and I will show you later how it works. But actually, it's some graph or structure of your objects, and client can request what it needs. So there is some very simple example. I have some query. It's object in JSON-like syntax. So I use braces and I request some video because I have a video field in my root object, and I put parameter ID. So I want some video with ID 1, and I want ID and name for that video, and as a response I get some JSON with the very same structure, but with values filled. So something more interesting, because I can have some field which some relation to other type. Actually, I have again my video, but I want to get some related videos or information, some piece of information about related videos. I put some parameter to restrict the number of these related videos, so I will get something like that. Again, information about in the related, I have an array of information about some related videos. For example, GraphQL has usually some binding to HTTP. It's served over HTTP. Usually I have single endpoint, so something like /query, and client should send some query as a string. It's usually supplied as an argument in query parameters or as body of the post request. And again, I will get some JSON. The JSON, the GraphQL response is packed in data field, and of course I can get some error message if something went wrong. GraphQL supports mutations and subscriptions because or I was talking about queries which should not change data in the server. Mutations are technically same thing, but using the parameters, I can change something on the server, but at the same time, I will get same data. I will want to talk about subscriptions today. They are very similar, but they are used to push data to client when something changes. So, but it requires, of course, some modification in the binding, because I cannot use ordinary HTTP request response, but I need to use something like WebSocket or things like that. So, when to use GraphQL? What is good for? I believe it's good for creating APIs for client applications. It's not much good for microservices or internal services and things like that, but for things like clients, smartphones, TVs, and other devices, because they are usually connected over internet. So I have problems with round-trip time, limited bandwidth, and one thing is that usually application needs multiple pieces, small pieces of different data. I will show you an example later, and new modern applications usually fetches data progressively. They want to fetch some piece to display, and later they fetches another thing. So I need to provide API which supports that easily. I will try to compare it with REST. In REST, resources are identified by URL, and I have some usually HTTP standard methods to query, modify, delete data, and so on. But there are two problems. The thing is, I actually there's screenshot from YouTube, and there are several pieces of information. I have video, and it has URL, it has some title, description, number of views, and there is some user who uploaded the video. And again, I have some related videos here, and for each video, I have some uploader and number of views, and I have comments, and for each comment again is submitted by some user. So I have same information repeated multiple times on different places, and of course I don't want to download the list of all videos from YouTube. It's insane. I just want some part of the video list, some top 10 related videos, for example. And but if I click to some video, I will get similar information, but about the video. And again, I need some little piece of information about this video. So the thing is, I need small pieces about different things. But if I create REST API, I usually need to request each piece of information individually, or create some related parameter to fetch related data with the main data I requested, but it's not systematic approach. And another option to design API is RPC, of course. The problem with RPC is ad hoc, because application programmer comes and says, I need some function to fetch this data if I supply these parameters, and later, but I need to get this data too, but not this one, and I want to parameter it this way, and I need to create new functions, operations to fulfill their needs. But I want to create some simple API, and that's why I believe GraphQL is a good choice. I will now show you some implementations in Go libraries, actually 2 of them. The problem is with the names, because both mentions GraphQL Go, Go. So I will refer to them as first one and second one, and third one. So we will start with the first one. Actually, it's full-featured re-implementation of reference implementation in JavaScript. It has all features, but it uses some, let's say, old-school approach. I will show you later. You don't need to provide schema, because you define schema in the code. But the advantage is that you can use some general constructions if your model is a generic one, because you have some inheritance or something like that, or those same interfaces for different types. We will see. So there is some example of resolver. Resolver is something which should resolve one field or type in GraphQL. As you can see, here you need to describe the schema. So I will define a new object type. I named video. I need to list fields. The first one is name, its type is string, and so on. The more interesting is comments, because comments is something which should return array, and it has an argument. I need to define argument here too. It's count. It has default value, but in the case of name, I did not mention any resolver for that field, because in my example I used some default function. What it does, it takes underlying source object and reads the field with the same name. So if I have object with name field, but the name is uppercase with uppercase first letter, but detail. So this default function fetches this data and provides it. But comments are more complicated. So I need to provide some resolve functions. As you can see, again, it's very generic one. So it returns empty interface and so on. I need to retype source object from the provided parameter and so on. Then I can fetch videos from some sample model and return it. Then, now there is the main functionality. I can take GraphQL functioning schema. I provided root resolver. It's the resolver for the root object in schema, and just say do this request, and it returns some JSON or object structure of objects which can be encoded to JSON simply. But there is a other library. The second one, it uses, I think, more Go-like approach. It uses a reflection to map resolvers to schema, or vice versa. You need to provide schema as a string, but the main advantage is it validates resolvers. Your resolvers encode to schema. As you can see, now it looks like more like Go code. You define just your resolver, its type, and methods with the same name on this type. Again, there is some related resolver. It's a resolver that should return related videos. It has argument, its type. So I can again fetch sample videos from my model and supply it. All I do here is I use the count arguments to limit number of returned items. So there is a main part of the code. I just read the schema from file, put it to a function, put rule to resolver, and I can handle request. This library is bundled with handle HTTP binding, so I can create HTTP interface very easily. I won't cover the third library. It's quite different. It does not support all features, but it should be fast. It's designed for efficient resolving. I created an example. It's on GitHub. It uses one sample model, but these two libraries with same HTTP interface. So you can request the data. I can show you some example. I will just start server. It uses this simple schema. I have some user, comment, videos, and I have related videos and comments for videos. And I have created resolvers in both libraries, so you can compare both approaches. And there is the second library running right now, the Gophers version, and I can send requests. I can change, of course. For example, I want to get just the first related video. I can limit it here, and you can see I got just one video. I can change what I get, which fields I get for related videos, because, for example, I'm interested in IDs. And so there are, of course, some problems. The GraphQL is quite a generic description of data you want to get. But if you remember the example, I have videos and related videos, and these videos has a user who submitted the video. But as you go deeper and deeper, number of fetches can increase. Actually, it's in some databases, in relational databases especially, it's not efficient to request one piece of data, one row one by one. It can be solved. The keyword is data loader. The libraries usually allow the resolvers to return not the data, but functions which returns the data. It's called func. And these funcs are returned in depth order, but are resolved in breadth-first order in the graph. So when the first function is called, I know all, for example, all the related videos, for which I will resolve a user. So I can fetch all users at the same time and provide users from some request cache. Another problem is DOS protection. I mean protection against the denial of service attack, because some malicious user can design query in such a way it's very difficult, it's very hard to resolve, because there is a lot of data and so on. So I need to limit the query somehow. There are some approaches One is depth and size, which use the query itself. They can be run on the query before it actually starts to be resolved. Or I can use some amount limit. It counts the number of items resolved during the query, and of course I should send some timeout to resolve the query. Unfortunately, in Go libraries, this functionality is not included. You need to implement it. But in the first one, there is some functionality to allow that. And finally, I will describe you our use case and the reason why I'm talking about GraphQL. We need to design API for TV applications. We have some content, and the content is categories, and the applications need to request the content with the least queries as possible, but not to overfetch. I mean, not to get data that the application don't need, because the application runs on smart TV, for example, and it's compared to laptop, it's very low-end device. The memory and CPU is not so powerful. And another reason is we need to be able to provide some way to dynamically load pieces of data, because I can have hundreds of channels and thousands of events in the channel history, and applications need some way to fetch pieces of data they need, and I don't want to create functions for each this case, and GraphQL is general enough to describe such a request. And I think, yeah, that's all from me. So, do you have any questions?
A question, how is it transported over network? Does it use HTTP or?
GraphQL itself works like I provide a string query, and I will get structure of objects. But the usual binding is to HTTP, so I use HTTP request usually. But actually, it's not about GraphQL itself, but the usual implementation is over HTTP, and it's encoded as JSON usually.
Okay.
What's your question?
Another question? Yeah.
I have a question about mutations, because you said that this GraphQL is quite generic, or it's generic language for queries. But what about mutations? Because I think you can design a REST API like simple select, update, delete. But you can create API, which is I think this is a bad approach to design API this way. And sometimes you need to hide some business logic and create a REST API that covers more sophisticated business logic. And I think this generic approach means you have a lot of business logic in your client, because the client needs to know how to ask, how data are structured. So I would like to.
Yeah,
I would like you to ask
There's
you about
actually two questions, maybe.
maybe more questions
about mutations. Yeah, as I said, it's good for client applications, and the amount of modifications by application, especially in our case, it's pretty low compared to queries. The amount of modifications to model is very limited. I can do such little thing, such few things that it's not a problem for us. But if you want to design some management system for accounting system or something like that, the REST API is better, I would say. Yeah, because you need to provide some objects to modify each of data. Of course, you could use GraphQL capability to define structure and to do mutations in the middle of the tree, but it will be difficult to implement, I believe. Yeah, that's why I was saying it's for client applications. Because if you create data, it's usually much simpler than requesting data, because when you create, for example, new command to video, you create one object. But if you want to show video in page, you request info about video, related videos, comments, users, and so on. And the other part of your question, that the client needs to know structure of the data. Yeah, it needs to know it, but if it does not know it, it's not able to display it or interpret it. And I provide a schema, so it requests only fields which the client understands. So what's the point to get data which client does not understand? Okay. Okay, any other question?
Oh, well, I would like to ask, the point of GraphQL is to create some generic API which can access almost anything. But what's the point of implementing it, let's say, in Go, when there are some implementations in JavaScript like Prisma, I think it's Prisma called, which can generate the whole pack of resolvers just from the schema. And you don't need to program it almost at all. And you have just generic API either way.
Because if you want to have your program in Go, yeah,
it's
that simple.
Sure,
I want to use other Go capabilities. I want to cache responses or cache data for responses and so on, and or use Go routines and things like that. Yeah, but you are right. There is no tool to generate directly. But I can say that the second library, the Go, is quite easy to implement. I can imagine I would be able to create such generator.
And do you have it in production? This library?
Not yet. We are
sledovanitv, or
no.
experiment, or
we are going to use it. I have some prototype because I wanted to find some problems in the design. But yeah, I was able to model our data to GraphQL quite easily. Another question?
And do these libraries provide some mechanisms for access control, or that I may have some data that somebody shouldn't access?
Yeah, of course, I didn't cover it in my presentation, but all resolvers can get context. So you can carry some authorization in queries to your resolvers. So you are able to say, oh, this user is trying to access this data. So you can decide. Okay. So thank you.
Right.